Okay, for all you lactose intolerant people, this may not be a great lesson, but here we go. If 16 people try to share an 8-piece pizza, so here you go, here's your 8-piece pizza, okay? How many pieces does each person get? Assume everybody wants the same amount of pizza. Okay, so you have 16 people, you only have 8 slices. What are you going to have to do with each slice? Well, you're going to have to cut each slice, in half so that you get 16 slices. So what we're dealing with now is we're dealing with fractions. I knew, that's why I didn't want to give it up before. Okay, so we're dealing with fractions. So let's take a look more closely at fractions. Okay, so here we go. A fraction is actually called a rational number. Okay, does that mean there are irrational numbers? Oh, maybe. But a fraction is actually called a rational number, and the definition is a fraction is in the form a over b, that's what makes it a fraction, where a and b are integers. Let me explain that. Okay? Remember the integers, that's the z, the integers are the negatives, 0, the positives. So you don't really have a fraction if you have a decimal on the top. So this is not really a proper fraction. That's not really a fraction yet. That's not a rational number. You have to get rid of the decimal point, and we'll talk more about decimals later. Okay? So you can't have decimals within fractions, otherwise they're not fractions. Okay. So a over b, where a and b are integers, and b cannot be 0. Let's talk about what that says. First of all, the top number of a fraction is called the numerator. The bottom number of the fraction is called the denominator. Okay? So this is saying that the denominator can't be 0. Why not? Well, let's recall something we did earlier. If my denominator is 0, it means we're dividing by 0. And remember, we cannot divide by 0 because we have something that's undefined. Okay? Because nothing times 0 will give me that number. So remember, all we have is a fraction. That's a rational number. And rational numbers are fractions, or any number that can be expressed as a fraction. Any number that can be expressed as a fraction. Its symbol is a Q. That means integers, if you think about it, can be written like fractions. Because if you have the number 2, I can write 2 as 2 over 1. So every integer can be written as a fraction. Okay, every whole number can be written as a fraction. Every natural number can be written as a fraction. Let me show you by taking a look over here and show you how they are all related. Our numbers just keep growing and growing and growing. Again, remember, we have natural numbers. Our natural numbers were the 1, the 2, the 3. I'm going to get so annoying, you're never going to forget this. Then, have I achieved that already? Okay. Then we have the whole numbers, and I had to add a 0. Then I had the integers. The integers add all the negatives, okay? Not the negative decimals or fractions, but all the negative numbers, okay? Whole numbers and their opposites, remember. Okay, so let me just give you one integer in there, okay? Now we have a new set of numbers we just talked about. Oh my gosh, this is the big mama, the big mama. Okay, these are the rational numbers. The rational numbers are your fractions, or any number that can be written as a fraction. Notice all of these numbers, if I take all of these off, all of the natural, all of the whole, all of the integers, they're all in the rational numbers because they can all be written like a fraction, like negative 2 over 1, 0 over 1, 2 over 1, 1 over 1. Okay, so they can all be written as a fraction. Okay, but not all rational numbers can be written as integers. For instance, the number 3/5 is not an integer. The number 3/5 is not a whole number. The number 3/5 is not a natural number. But if you think about the number 3 over 3, that's a fraction, but 3 over 3 is 1. So that's a rational number that's in integers, whole, and natural. Because it's really 1, it's really this number right here. So any fraction that reduces to something that's natural, whole, or an integer are in one of these other sets of numbers. And that's how they're related. Let's take a closer look at fractions as we look at your workbook and show you these colored parts. Okay, so the first one you see is that 1/4. And it says 1/4 is shaded, okay? And what they have is a little square here. and they're using the whole square as one. I'm sorry, they're using the whole square. They broke up the whole square into fourths. These are each 1/4, but they're saying 1/4 is shaded. Okay, so that's 1/4. And what this means is we have 4 equal parts, 4 equal parts, and one is how many is shaded. Okay, so the bottom or the denominator always talks about how many equal parts your whole is broken up into. All right, this is kind of cool. Here's my 1, okay, and again, 1 could be represented by a big circle, 1 could be represented by a big square, but my 1 is just this line here, okay, or this bar. And when you break up the 1, okay, into different pieces, 12 pieces, you're actually going to get smaller pieces. Think about this. I think it's important for you to see and visualize fractions because it's a lot easier for me to talk about them if you kind of get a feeling for what they look like. Okay? If I break it up into 12 pieces, those pieces are going to be really, really small. If I break it up into 2 pieces, those pieces are not going to be that small. Okay? Same thing. So as we break it up into more and more pieces, fourths means 4 equal pieces, 6 means 6 equal pieces, 12 means 12 equal pieces. As you break it up into more and more pieces, those pieces actually get smaller, which makes sense. Which is why you don't want to split a pie with 16 people. You only want to split a pie with 2 people, so you get lots of pie. Okay, let's take a look at the next thing in your workbook. The next thing in your workbook asks to compare the following fractions to 1. So it's 1/2, 2/3, 1/4, 5/6. So I'm going to do that by taking this 1, and then I'm going to use the 1/2. This is 1/2. Well, how does that compare to 1? Well, 1/2 is obviously less than 1. Well, that makes perfect sense. 1/2 is less than 1. Now let's do 2/3. Oh, you're thinking I don't have a thirds pieces, but I do. It's okay. I'll show you these are third pieces by putting them together. If these really are third pieces, that means 3 of them, right, would make a whole. There's my thirds, but I want 2/3, so I only want 2 of them. So 2/3 is less than 1. You're thinking, I know this. I know. Just watch the show for a minute. Okay, now let's do 1/4. Well, these are fourths. 1/4 is obviously smaller than 1. It's less than 1. Now let's do 5/6. Ah, not worried, are you? Because you see those 6 pieces, right? All right, so let's do 5/6. Let's get this 1/4 out of here. Three, 4, 5. There's your 5/6, and obviously 5/6 is less than 1. Okay, so that's how they compare to 1. Okay, let's look at the top number. Let's look at the bottom number. The bottom number represents, remember, how many equal pieces. It's okay, I'm good. Your whole is broken up into. Good thing that's not a human. Okay, how many equal pieces? So 1/2 means you're broken up into 2 equal pieces. The top tells you how many of those pieces you want. Want a shade or just one. Okay, 2/3 means you're broken up into 3 equal pieces. And this is what it says in your workbook. The bottom is how many equal pieces you're broken up into. But the top tells me how many of those pieces I want. Same thing all the way down. Okay? All right, so let's take a look at another example as soon as I get my piece. All right, now I'm going to draw these. Now, you should know how good of a drawer I am by now. I'm going to give this my best shot. I'm just going to move these over to this side of the board. Cranky. These 6 pieces are cranky. Okay, here we go. The first one is 2/3. Okay, so I'm going to draw 2/3. Now, I could actually draw anything I want, but you've seen me draw, so I'm probably just going to use like a piece like that, a little rectangle. Now, please let me explain this. This is not going to look as good as it should. When I draw this, let's think about how many equal pieces I should draw it in. I should draw it in 3 equal pieces because that's what the bottom tells me. But here's the problem. Did you hear that word equal? I have to make these 3 equal pieces. Okay, so I'm going to do my best. And then we're going to pretend that those are equal. So those are 3 equal pieces. Okay, if you want to see 3 equal pieces, I'll show you 3 equal pieces. Here's 3 equal pieces. Right? There's 3 equal pieces. Okay, there's 3 equal pieces. I want 2 of them, 2/3. So there's my drawing of 2/3. So we're kind of pretending they're equal. The next one is 5/5. Well, let's talk about 5/5. 5/5 means I have to break this up into 5 equal pieces. Look, I can't even draw the rectangle straight. How could I draw that, possibly draw it into equal pieces? Okay. Let's try that again. 5/5. Oh, yeah, it's so much better. Oh, we're in trouble. 5/5 may be bigger than me. 5/5 may be more than I could really do. Here we go. I can do it. I feel it. All right, drum roll. All right, good. Okay, there's 5 equal pieces. Yes, they are incredibly equal. All right, that's the beauty of the pen. Okay, and you want 5 equal pieces, 5/5. You want 5 of them, which is the whole thing. Okay, which is why, think about this, 5/5 really equals 1. Okay, so we're all good. Now we're going to do 7/4. Oh, that's just going to be so much fun. I'm already sweating here. 7/4. Remember that math anxiety you had on that first lesson when you learned about that 0? Okay, well, I'm having a little math anxiety worrying about these 7/4. But I can do it. I'm feeling good now. I'm feeling good. Let's do 7/4. Okay, so I'm going to take this one. I'm going to break it up into fourths. These are equal. That's not bad. That's not bad. Not bad. Okay, those are fourths, but I only have 4 of them. And you know, don't make fun unless you can do it. Oh, look. Some people aren't blessed with the skill of being an artist. Okay, so I need, those are fourths. They're supposed to be all the same size. That's not bad, but I need how many more? If I already got 4 fourths, I need 5, 6, 7. There is 7/4. So here's the point. Let's see what the point is. This is greater than 1. This is less than 1. This is equal to 1. So we should be able to tell what fractions are greater than 1, less than 1, or equal to 1 by looking at their numerator and denominator. Remember, the top number is the numerator, the bottom number is the denominator. So let's talk about that. When the top number and the bottom number are equal, that's when they will be equal to 1. Okay? When the top number is bigger than the bottom number, okay, that's when it's greater than 1. And when the top number, which is the numerator, is less than the denominator, that's when it's less than 1. Notice, top number less than, or numerator less than a denominator, less than 1. Numerator less than denominator, less than 1. So that's how you know. And this is called improper fraction. When it's greater than 1. When it's less than 1, it's called a proper fraction. When it's equal to 1, it is also called an improper fraction. Okay, so that's what we know. And all that stuff is in your notebook, so in your workbook, so don't worry about that. Okay, in the next set of examples, we're going to state the numerator and denominator of each fraction, state whether they're proper or improper, and compare it to 1. So here we go. All right, so you saw the little manipulators that I dropped all over the floor, but that's cool. All right, now we're going to just summarize this thing. The numerator, remember, is the top number. Oh, let's try this again. The numerator is the top number. The denominator is the bottom number. And we want to know if it's proper or improper and how it compares to 1. Well, because the numerator is less than the denominator, this is a proper fraction, and it's less than 1. Okay? So now let's look at 5/5. Here, oh, well, this is an easy question. The numerator is 5, the denominator is 5. And the numerator equals the denominator. The numerator equals the denominator. So that makes that a improper fraction because it's equal to 1. And you knew it was equal to 1, right? That whole division rule. Okay, numerator, denominator. The numerator here is 7. The denominator is 4. And I remember denominator, if you confuse them, denominator D for down. Denominator's down, D for down. The denominator's down, okay? And here, the numerator is greater than the denominator, so this fraction is greater than 1. And you saw that, right? Okay, so this one is the numerator is greater than the denominator. It's greater than 1, so it is an improper fraction. So remember that improper fractions are greater than 1, and proper fractions are less than 1. Now let's do something we've already really done before, just to review it. Okay? Because I know you think and eat math, you know, think, eat, and sleep math, so you remember everything. But just in case you don't, okay. Here we go. Number 1, 3 over 1. Remember, a fraction line is really just a division line. 3 divided by 1 we have negative 3 divided by negative 3. We have 0 divided by 3. And we have, finally, 3 divided by 0. 3 divided by 1 is 3. Remember, I could check that if I want. And also notice the numerator is greater than the denominator, so that is called an improper fraction. The answer is 3. This is 1. This is 0. And this, of course, is undefined. The 0 is under, so it's undefined. And remember why, but that's a bad trick, I guess. It helps me remember, but I have to make sure you understand why. There's no number times 0 that'll give me 3. So that's why it's called undefined. Okay, so that's what we've already done. All right, now let's graph some fractions. We're going to do this on separate number lines. Okay, first one we're going to do, now listen, you know what I've noticed in the 150 years I've been teaching? I know I don't look that old, but I've noticed that people have a hard time with a ruler. They don't really know. Yeah, that was a ruler. You know those things you measure with? Sorry if I said that bad. But anyway, they don't really know how to measure that. I mean, how to read a ruler. So I know rulers don't come in fifths, but I just want to explain, they usually come in sixteenths, but I just want to explain this, is that if I'm going to start here at 0. Now, I'm going to break this up into fifths. So I would have 1/5, 2/5, 3/5. I'm going to keep going. I know I could be done. 4/5, 5. This is 5/5, but 5/5 is really 1. So 1, 2, 3, 4, 5. You need 5, because 5. You need 5 spots before you get to 5, because you'll be at 5/5. So this is 3/5 right here. I just want to make sure you understand that you'd have 1/5, 2/5, 3/5, 4/5, 5/5 broken up into 5 equal places. Let's look at negative 2/3. And notice again, what this proves is that that's a proper fraction. It is smaller than 1, because here's 1, and your 3/5 is less than 1. Let's do negative 2/3. Well, negative 2/3 is obviously on the negative side or the left side, and this is broken up into thirds. So this is negative 1/3, negative 2/3, and this would be negative 3/3, negative 3/3, or negative 1. Okay, and that's where you are right here. Again, show you there's three spots because you're dividing into 3 places. Okay, and finally 1/2. Here's 0. Here's 1/2. Well, the next one would be 2 over 2, which would be 1. Okay, because only 2 spots you need to get to 1, because you break it up into 2. So there's your 1/2. Okay. Before I actually do this next problem that's in your notes, I want to just ask you something. If you have a whole orange, throw me an orange. This is good. I want this. If I catch it. If you have a whole orange, okay, and you have a half an orange, okay, I can't really cut this. So if you have a half an orange, if you have a whole orange and you have a half an orange, I think this might be a tangerine, but who cares? Okay, no, I think it's an orange. All right, you have a whole orange, you have a half an orange. What do you really have? Well, you would really have 1½ oranges. Let's talk about that. So we have 1 plus a half is 1½ Okay, now notice, in algebra, if we have 2x, I don't need to put a symbol in there, and I know it's attached by multiplication. However, there's no symbol here. It's not attached by multiplication. It's actually attached by addition. That little rule only works with variables. This is actually attached by addition. 1 plus a half is 1½ okay? And this is called a mixed number. We're going to get to this right now as I do the next problem. But a mixed number has two parts. It has a whole number part, right? And that's the 1. And it's got a fraction part. And that's the 1/2. So let's now take a look at this next problem. If I work 5 whole days and then 1/3 of a day, so I'm working 5 days, plus I'm going to work another 1/3 of a day, okay? How many days have I worked in total? Okay, so let's take a look at this. Well, I'm working 5 days plus 1/3 of a day, which is just 5 1/3. That's it. That's all you have to do when you have a whole number. It's a whole number and a fraction part. You just get back a mixed number. So let's just take a look at this if I draw it. Oh, draw it. That sounded terrible, but I'm going to say it anyway. Draw it. Here we go. All right, ready? I'm going to draw it. Because of this third, I'm going to draw it into thirds. Watch. 1, 2. Remember, they're equal. Sorry. Okay. Watch this. I know. It's going to take a minute. Hold on. 1, 2. One, two. Oh, that's supposed to be the same size. 3. Supposed to be the same size. Bear with me. 4. Supposed to be the same size. Bear with me. 5. Up. That's not even the same length. That's really pushing it with you, isn't it? Okay. So here's what I got for 5 1/3. All right, here we go. This is incredible drawing. Okay. So, 5 1/3. 1, 2, 3, 4, 5. I went crazy. I went shading crazy. Okay. Now let's count up the thirds. So I have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3, 13/3, 14/3, 15/3, 16/3. So I know 5 1/3 is the same as 16/3. Okay, so improper fractions greater than 1. Okay, greater than 1 can be written as a mixed number. So let me kind of just talk about that for a second, and then I'll show you how to do it a quick way without this big drawing, because, you know, you may not be as artistic as I am, so you may not want to do it. So here's the deal. The deal is, remember, there are 2 types of improper fractions. There are improper fractions, like this, 16/3, where the numerator is greater than the denominator. And then there are improper fractions where the numerator is equal to the denominator. Well, that's 1. So that's not a mixed number. So you cannot change these improper fractions to mixed numbers. They just become whole numbers. But you can change these. Okay, so improper fractions greater than 1. So this is the type that's greater than 1. And we already know that. Can be changed to mixed numbers. All right, so let me show you how to do it. It is so simple. You're going to love it. All right. Now, changing a Changing an improper fraction to a mixed number is not the same as reducing it. It is just changing its form, okay? So here's how it works. If I have 5 1/3, and let me make that 5 bigger, and I want to change that to that 16/3 without doing all that unnecessary drawing, because I am awful at it, here's what we do. We multiply the denominator and the whole number, and we add the numerator, and we put that over the denominator. So watch. It goes over the denominator, so 3 is the denominator, and then you just multiply. 3 times 5 is 15, plus 1 is 16. There's your 16/3, which is what the same answer you got when I drew the whole thing out. So that's all you do. You multiply the denominator by the whole number, add the numerator, and then put it over the denominator. Pretty easy. So you're going to get to try some. Give them your best shot, and then we'll look at the answers together. All right, let's see how you did on these. Remember we said that any improper fraction greater than 1 can be written as a mixed number. So if these are mixed numbers, then we're going to get back an improper fraction greater than 1. So let's take a look at it. Okay, so we said we multiplied. 3 times 7 is 21, plus 2 is 23, and we write that over the denominator. So 23/3 is your answer there. Okay, now here, maybe it might be easy to put the denominator down first. Okay, 5 times 3 is 15, plus 4 is 19. So every time I do these, I'm going to write the denominator down first, because that never changes. Okay, so write the 9 down. 9 times 5 is 45, plus 1 is 46. So it's 46/9. Really, really, really easy. Okay, let's talk about what happens if you have a negative mixed number. Okay, so let's take a look at that. You might think that's a little harder when seriously it's not. Okay, so remember we said that a whole number plus a fraction is a mixed number. So let's take a look at these two examples at the same time. Let's take a look at 5 1/3, back to him, and negative 5 1/3. Okay, this actually came from 5 plus 1/3, right? We talked about that earlier. This actually comes from, watch, negative 5 plus a negative 1/3. Which is actually negative 5 1/3. Because think about this. I owe you 5, and I owe, oh, there's that double, but there's that double sign. We can get rid of that double sign, because we have been. I'll just do that. I will just do that again. Okay, watch. I could write it like this if I want to, right? Double sign, signs are different, changes to a negative. Because this means I owe you 5, I owe you 1/3, so I owe you 5 1/3. Okay, so that's where you go in here. So it's very simple. Okay, still combining that whole number and that fraction to get your mixed number. What happens if I want to go, well, let's think about this. What happens if I want to change this? Just think about this so we don't get confused. If I want to change this to an improper fraction, well, all I have to do is bring down the negative. Don't disregard it. Just bring it down. Don't do anything with it in the problem. Don't go 3 times negative 5. I wouldn't do that. Just bring it down. And I go 3 times 5. Oh, hello. I wouldn't write that down either. All right. In fact, let's go back to writing your 3 down. 3 times 5 is 15, plus 1 is 16. It's just negative 16/3. Okay? So just bring it down. Don't go 3 times negative 5 plus 1. You're not going to get the right answer there. So just bring down the negative and deal with this. So 3 times 5 is 15, plus 1 is 16, over to 3. Okay? So be careful there. Really very simple, but unless it's explained to you once, you may not understand how it goes. All right, what about going the other way? All right, let's look at 13/5. And let's see if we draw it, what that really means, 13/5. Okay, I'm drawing again. We're in trouble. All right, oh, when it's fifths. You saw how good I was with that before, didn't you? You might be able to realize what's already going to happen. Oh, that's a beautiful rectangle, isn't it? Okay. Hey, that's not bad for me. That's not bad. I could be getting an award soon. Okay, so we have 1/5, 2/5, 3/5, 4/5, 5/5. 6/5, 7/5, 8/5, 9/5, 10/5. I need 3 more fifths, right? So, but I need fifths, so they have to be the same size. Because this size, well, you know, we're pretending they're the same. This size is a fifth. So that's 10, that's 11, 12, 13 fifths. So that's really 2 holes. Not holes like hole in your shirt, you know, 2 hole. Okay. At 3 fifths. So that really is equal to that. So 13 fifths is really 2 and 3 fifths. You might have figured that out already because you might have said, well, I need 2 rows of 5, and then there'll be 3 left over. So watch how you do this. Let's see how you make this change. Here's how you make the change. Remember, this is a division sign. All you do, and I like to do it just like that to make sure you understand what you're dividing. I am doing this. I'm putting the 5 in a 13. I'm going 5 goes into 13 twice. That would make 10 with a remainder of 3. So now we're going to convert this to my answer. It's 2 wholes, 3 left over, always over your same denominator. So it's 2 and 3 fifths. So that's how you convert from this improper fraction to a mixed number. You just use division, okay? So let's look at some examples. I'll do this next one with you, and then you can do the 2 that are left. So remember, we're dividing. Again, we might want to get in the habit of putting down a denominator first. That might make it easier. So let's take a look at 17 fifths. Let's make sure there's no negatives here creeping up on the board. Okay. Change into a mixed number. Okay. 5 goes into 17 3 times. That's 15, and we get a remainder 2. So here's what I know. I know my denominator is going to be 5. Okay, my whole number part is 3. My remainder is 2. So 17 fifths is 3 and 2 fifths. I could check myself. Watch me check myself. 5 times 3 is 15, plus 2 is 17, 17 fifths. So it might be a good idea to check. Okay, so if you'd work on the other 2, and then we'll look at it together. All right, let's see how you did. Here we go. We're going to divide here. Well, okay. 4 into 23. 4 goes into 23 5 times. 4 times 5 is 20. We subtract. We get a remainder of 3. So remember how this goes. The fractions, the denominator is always going to stay the same no matter which way we go. Improper fraction to mixed number or vice versa. And now the whole number is 5. Remainder 3. So it's 5 and 3/4. We can check ourselves. 4 times 5 is 20, plus 3 is 23/4. So that works out. 62 over 3. Okay? We get 20. 3 times 20 is, I did a little short division there. 3 times 20 is 60. We get a remainder of 2. Okay? So remember, the denominator stays the same. 20 is our whole number. Remainder goes in the numerator. So it's 20 and 2/3. And we can check ourselves. 3 times 20 is 60, plus 2 is 62 over 3. Awesome. But remember, this is just changing its form. That's what it's called, changing its form. From an improper fraction to a mixed number. All right. Let's take a look at how we can possibly write a negative fraction. So let's take a look at this fraction, this fraction, this fraction. I think I skipped one, but I'll put it here. You know what? Let me put it in the same order you have it in. Okay, let me put this one. This fraction. They almost look alike, but okay. The biggest problem people have with negative fractions is they don't know where to put the negative. They're like, all right, I'll write the fraction. You want me to make it negative? Okay, I'll put the negative right here because I don't really know where to put it. So they line it up. Now, you can do that, but you need to understand that it doesn't matter. Let's take a look. This fraction is clearly positive, okay? That's 1/2. That's clearly positive. I can see it as positive, This fraction is clearly negative because that's the negative right in front of it. Right by the line. Let me line it up. Okay, now here's the other three issues. Let's take a look at this one. I don't actually have to divide, but I know that if I did divide, a negative divided by a negative would be a positive. So I should never see a fraction that looks like this, because when I simplify it, that's going to be a positive, because a negative divided by a negative is a positive. I don't have to actually divide. And if I did divide this, remember it's a number smaller than 1, so I'm going to get a decimal number out of it. Okay? So these are both positive. That one is positive, this one is positive, and this one is positive. Now let's go to the negative sides. We know this is negative. Now let's look at this one. Again, we're not going to divide any of these. We don't want the decimal. We want the fraction. Okay, so this one has a negative in the numerator, but no sign in the denominator. If there's no sign, it means it's positive. So that's a negative divided by a positive, which makes it a negative. So again, I don't have to actually divide. I just know that fraction is negative. Here, a positive divided by a negative, that's also going to be negative. So here's what you have to know. If you have a negative sign in only one place, either in the middle or only on the top or only on the bottom, that's still a negative fraction. These are equivalent fractions. I should never see that. That should always be changed to positive 1/2. Okay? Actually, but when I write it, my answer, they wanted me to group my like fractions together. So these are both positive, but I never should see this. Okay? These are all negative, and it doesn't matter what you see. Okay? Sometimes this is a little easy to work with, we'll see later on, but it doesn't matter what you see. All right, well, just like before we talked about absolute value with whole numbers and natural numbers, we can talk about absolute value with fractions. And it's the same kind of thing. Absolute value is the distance you are from 0 on the number line, the number of units. So let's take a look at these two next questions. It says evaluate. That means we're going to get a number answer, remember? So let's look at number 1. Okay, 7/8. Absolute value of 7/8. So what they're asking is, if I'm on the number line, how many units is 7/8 from 0? 7/8. That's it. It's 7/8 units. Here, absolute value, distance from 0. If I'm at negative 2/3, how many units am I from 0? 2/3. I'm just in a negative direction. So I'm 2/3 units in the negative direction. You do the same thing we did with whole numbers, okay? And that takes care of that. Next time we see you, we're going to be reducing fractions.